In this video, we're going to be going over properties of a rhombus, and we're going to go over applying these properties in some numerical examples as well. So just to get you guys a heads up, rhombi is the plural form of rhombus. So if you see the word that looks like this, that just means that there are multiple rhombuses. That's the correct way to say it, is rhombi. So we're going to go over the family tree portion of this first so you guys can kind of get a visual example of which properties we are inheriting from the shapes before. So lift up every flap from the square. So you should be on the very last one. You're lifting up every flap that's in yellow, and you are writing on the family tree. So far, we've done all of this, right? In the last video, we were dealing with the rectangle, which is one type of parallelogram. But what we're doing now in this video, here we have a rhombus, which is the second type of parallelogram that we're going to be studying. Now, what you should see is when you have this family tree, you should see that the rhombus does not inherit any properties of the rectangle, but it does inherit all of the properties of the shapes above it. So a rhombus inherits all of the shapes of a parallelogram and all of the properties of a quadrilateral as well. Okay, so make sure you guys write this in your family tree. Now we're going to write the specific properties of a rhombus, so make sure you're lifting up all of the flaps that are in yellow, and then you can write this stuff down. So again, this is a specific type of parallelogram, which means that it's inheriting all of the properties of a parallelogram and a quadrilateral as well. And then there are a few more properties that help us classify it as a rhombus. So again, under your properties tab, you want to make sure that these new properties are really, really prevalent to you. Because at this point, we should be reinforcing, we should already know all of the properties of a parallelogram, right? So now, if you do know all of the properties of a parallelogram, you really only need to study these three new properties, and it's going to help you figure out what a rhombus actually is. So a rhombus is a parallelogram whose all four sides are congruent, whose diagonals are perpendicular, which means they meet at a 90-degree angle. And with this property, with property number 2, you can kind of see that we have 4 right triangles that are created, right? Now, it's interesting to see this because here, you'll probably need to use Pythagorean theorem somewhere, right? So remember, this is just some prior knowledge. We might have to use a squared plus b squared equals c squared because we can see these 4 right triangles created. This is, in fact, the only shape that we have from what we've done so far where 4 right angles are created, or 4 right triangles are created with our diagonal. So that's interesting to see. Now, another thing is that diagonals are bisecting the vertices of our shape. So when I say the vertices of our shape, I mean these 4 points, these 4 corners right here. Now, again, so far from what we've learned, a rhombus is the only shape where when we have our diagonals like this, we're actually cutting the angles here in half, right? And this is interesting because, again, this is the only shape that this happens with so far. So if you have a parallelogram and you see that the diagonals of your parallelogram are bisecting your angles just like this, then you know that you have a rhombus. Now, I didn't label property number 2 that well, but for property number 2, what you guys should see, all the diagonals are congruent. The diagonals are perpendicular. Oh, which we did label. Okay, so we're good there. So again, this picture is color-coded, so if you have highlighters or colored pens, you should go ahead and label it just like I did as well. Now, don't forget that this shape is still a parallelogram as well, right? So in the first diagram that we have here, we've labeled all of the new properties, but if you take a look at this diagram here, it gets a lot more complex, but that's because we're accounting for all of the properties of a parallelogram as well. Now, what you should remember is in a parallelogram, right, we have our opposite sides being parallel, right? So these 2 sides are parallel, and then separately we have these 2 sides being parallel as well. We also have that our diagonals are still bisecting each other, right? It's still a parallelogram. So that means that our diagonals, that this piece is going to be congruent to this piece, and that this piece is going to be congruent to this piece. And we also have that our opposite angles are congruent, right? So this isn't really that, it's not much of a different label, but that would mean that this entire angle here is congruent to this entire angle here, and then separately this entire angle here is congruent to that entire angle there, right? So you guys do need to know all of these things, but in the first diagram, we've just labeled the new properties there. Now, how to prove it? First, you always have to prove that your figure is a parallelogram first, right? So in your proof, you have to have a statement that says whatever, let's say quadrilateral ABCD is a parallelogram, and then your reason would be one of the 5 theorems or methods that we talked about back in the other video. So if you forgot, you can use your flipbook to go back to that. And then after you prove that it's a parallelogram, you have 3 different things that you can do. You can either show that all sides are congruent, right? So again, if you have a parallelogram where all sides are congruent, then you know that we have a rhombus, right? Now, method number 2 could be, again, you have to have a parallelogram, right? But once you prove a parallelogram, you can then show that your diagonals are perpendicular, because if you have a parallelogram whose diagonals are perpendicular, then you know that we have a rhombus. And then last but not least, once you prove a parallelogram, the last option is to show that the diagonals are bisecting the angles of the shape, or the vertices of a shape, because in a parallelogram, when their diagonals are bisecting these vertices, the only shape it could be, or we know for sure that it's a rhombus, right? Okay, now we're going to go over some numerical examples, so you want to make sure you are writing this in somewhere. If it's not in your flipbook, you need to make sure that it is in a neat, organized place that you know that you can refer back to. You can even go ahead and staple some extra papers onto your flipbook, like make a post-it or a small index card, and put it on your rhombus portion. So again, when we're doing these examples, you want to think about what property are we using. And again, I'll probably consistently go back to this slide where we're likely going to be referring to the three new properties of a rhombus, but we can still always refer back to any of the properties of a parallelogram as well, right? Because a rhombus is a type of parallelogram. So let's get right into this. So it says, given rhombus MATH with angle M equal to 74, it wants us to find angle MHA. So I already know angle MHA. We are looking for this angle right here. And the question tells us that this is a rhombus, right? Now, depending on the question, if it didn't say we have a rhombus, if it said that we had only like a quadrilateral, we wouldn't be able to use any of the properties, right? We need to know what shape it is in order to use whichever properties we're going to apply. So it says given rhombus MATH, and again, we're ending up looking for angle MHA. So what I like to do, I'll just start filling in my puzzle pieces. I fill in what I know. So I know that a rhombus is a parallelogram. And a symbol for parallelogram, if you guys didn't know from class, is you could do a P with a little box around it. So when you're doing your proofs, again, this is kind of a universal language. This little symbol that I just wrote means parallelogram. So I know, and you guys don't have to write all this out, but this is me listing out my thought process. I know that opposite angles are congruent. And the reason this is helping me is because I know I can go ahead and fill this in as 74 degrees, right? Excuse me. Now, I also know that all angles... So actually, let's go back to this first one. So opposite angles are congruent, right? So I labeled that angle T as 74, but then I also know that this entire angle is going to be congruent to this entire angle, right? So I also know that all angles sum or add to 360. So that's kind of going to help me find those two angles that I marked with the blue arc marks. If I label this angle here as x, I can go ahead and also label that as x, right? So using this property here, I can go ahead and make my equation. So if I do 74 plus 74 plus x, I know that's going to give me 360 degrees. And in my little calculator, we'll do 74 plus 74. That's going to give us 148 plus 2x equals 360. And then if we do 360 minus 148, we get 2x equals 212. And that's going to give us that x equals 106. So I'm going to go ahead and fill this in on my diagram. And these are the methods. See how I'm working very neat, very organized. So this entire angle is 106, and this entire angle is 106 degrees, right? But let's go back. I don't want that entire angle. It wants me to find the measure of angle MHA, right, which is that red angle right here that we've marked when we first started this problem. So another property that I know, right, and I'll make another little note over here, is that in a rhombus, the diagonals bisect the angles of the shape, right? And that's exactly what's happening, right? We have this angle, we have vertex H here, that's being broken up by this diagonal. So what I know is that this angle MHA right here, is going to be congruent to angle THA, which is right here, right? I know that that diagonal is splitting that big angle into two congruent parts, right? And I know the entire angle is 106 degrees. So if I take that 106 and I divide by 2, I'm going to get what each side is equal to, and that's going to be 53 degrees. So then I know In red, I know that this angle here, that little angle, is going to be 53 degrees, and then I know that this little part here is also going to be 53 degrees. Again, because that angle, just because we know it's a rhombus, right? In a rhombus, I know that my diagonals are cutting those angles in half, and that's only true in a rhombus. If this said it was a rectangle or a parallelogram, we wouldn't be able to do that, so that's why it's really important that the question tells us it's a rhombus. So these questions could take you a little while. You might have to go back and use some old properties of a parallelogram like we did in this first step here. But again, it's just kind of like building your story, filling in all the information that you can with what you're given, and then eventually, hopefully, you end up to what you're looking for. All right, last but not least, so it says in rhombus TIGE, diagonals TG and IE intersect at R. The perimeter is 68, so I'm going to write that out. I know the perimeter of this shape is 68, and I know that TG, which is this entire thing here, is 16, and it wants the length of the entire diagonal IE. So again, before I'm just going to start building my story here. I'm going to see what I can do with what I am given, and I'm going to start with the perimeter being 68. So again, we have that it's a rhombus, right? So I know I can use any of those three new properties that we learned about. So what's standing out to me right now is that, so my first step, I know in a rhombus, because I know perimeter, right? They give us perimeter for a reason, and perimeter is all sides added together, right? So in a rhombus, the property about sides that we're going to be using here is that in a rhombus, all sides are congruent. So if I know all sides are congruent and I know that the perimeter is 68, I can go ahead and just label all of my sides as X, right? Because whatever side TI is, that's going to be the same exact thing for all the other three sides. So again, I know that my perimeter is adding up all the sides. So 68 is going to be equal to taking X plus X plus X plus X, because that's what all four of my sides are going to be, right? So if I simplify, I'll get 68 equals 4X, and then I can go ahead and figure out what X is going to be, which is going to be 17. Now again, I'm going to go in my diagram and go ahead and label this so that I have a better understanding of the information we have versus the information that we still need. So I know each of my sides is 17. And now let's see what I can, so we've already dealt with this part of the given. Now let's see if we can do anything with that TG equals 16, right? So I know that a rhombus is also a parallelogram. And in a parallelogram, diagonals bisect each other. And again, you guys don't need to write all of this logic down. Like, at least you need to write down the formulas and solving for X and stuff, but this is me just writing down the thought process. So if you want to write it down, you can if it helps you. But again, I'm just kind of verbal or writing what I'm saying. So they tell us that the entire diagonal TG is 16, right? So I know that at this point R, where my diagonals are meeting, I know that each of my diagonals is being split into congruent parts. So that means that RG is going to be 8, and I know that TR is going to also be 8. So that kind of helps me with that. And another thing that I do know in a rhombus is that diagonals are perpendicular, right? And you don't really like whenever I see a rhombus, I'll go ahead and get in the habit of marking those 4 right angles, because the more important thing here is that there are 4 right triangles created. And as you get into practice with this, I want you guys labeling all of this stuff in your diagram, because it might help you. It might like give you an extra piece of info where you're like, oh, I know what to do now. And you know what? In my diagram, I'm gonna actually go ahead and erase that TG is 16, because just seeing the 8 and 8 is enough for us right now. Okay. Now let's see if we can do anything here. So we want the length of diagonal IE. So we're looking for this entire measurement right here. Now I don't think we can solve for it right away just yet, but we might be able to solve for part of it first. Now I'm going to highlight in this greenish color. Again, we have 4 right angles, right? So I'm just going to deal with, or 4 right triangles. I'm just going to deal with one of the right triangles because all 4 of them are going to be the same anyway. But I'm going to go ahead and redraw this right triangle, and maybe it's going to help us see what we need to do. So we have I, we have G, and we have R, right? We have that this value here is 17. We have a right angle, and we have that RG is 8, right? Now, my thought process here is if I find IR, using my prior knowledge, I'll be able to just find RE as well, right? Because again, we're going back to that property of our diagonals being bisected, which means that they're split into two congruent parts, right? So at R, similarly to how we broke up diagonal TG, we can break up diagonal IE, right? I know that this segment here is going to be congruent to this one. And I can use my prior knowledge to actually help me find this. I can use Pythagorean theorem, which is what we've mentioned when I introduce you guys to this property of your diagonals being perpendicular. So what you can do is use Pythagorean theorem to find what IR actually is. Now remember that your C value always needs to be your hypotenuse. So we have A squared plus B squared equals C squared. So we can do X squared plus 8 squared equals 17 squared. And if we simplify, we'll get X squared plus 64 equals, and I need a calculator for this, but it is going to be 289. Now, if you continue with your algebra, it's getting a little sloppy here, so I apologize for that. X squared equals, it's going to be 225. And then if we take the square root, we get x equals 15. Now, again, always go back to your diagram and think about what x actually represents. So 15 is representing the measure of IR, right? So here we know that it was 15. And again, we were able to use Pythagorean theorem because we know that in a rhombus, our diagonals, we use this property here, that they're perpendicular, right? Which means that 4 right triangles are created. Now again, I know that IR is 15, so which means I also know that ER is 15, right? Because that goes back to the property of our diagonals being bisected or split into two congruent parts, right? So where they meet at. Now we can find the length of diagonal IE. The length of diagonal IE is just IR plus RE. So in total, if we add those two together, we'll get that IE equals 15. So again, these problems can be long. They can be very multi-step, but that's why it's really, really important to just try to start building a story with your given information. Figure out with your given information what properties you're going to need to use. Then again, eventually, as you start building your story, you're going to eventually end up with the information that the question is actually looking for. But again, another piece of advice, always go back to your diagram, label information that you find. So if you get a value for x, a side length, or if you find a value of an angle, go back to your diagram and label that, because again, that's another piece of you building your story.